Hi, welcome to our MIT808 capstone project, an automated metadata mining and dataset recommendation system that we built for Innovation Africa.
Innovation Africa at UP is a collaborative research initiative that aims to promote sustainable Pan-African development and economic growth. One key aspect to achieving this is through encouraging collaboration between researchers, organizations, and institutions. To realize this, Innovation Africa at UP has developed a research repository platform where users can upload and share datasets, images, and other miscellaneous files called the Information Hub.
The purpose of this project is to assist users with finding datasets available on the Information Hub when they make use of the search bar. This is achieved by generating and storing metadata from each dataset in the Information Hub, and then secondly, from that collection of metadata, identifying and recommending possible datasets to users of the Information Hub.
To implement the automatic relationship mining approach, the following stepwise solution has been used. Firstly, identifying which metadata to collect from each dataset and automatically process and store the metadata upon data ingestion. Next, developing a recommendation model that uses the collected metadata to identify related datasets and projects.
The first step of recommending projects and datasets is to have a catalog of available datasets to choose from. The descriptive characteristics, the metadata of each dataset, needed to be extracted and stored for easy reference. The metadata mining process had several constraints. Any tabular dataset should be able to be imported. The metadata needed to be stored in the existing PostgreSQL database, and automated tagging needed to be performed on the datasets. The metadata schema was designed to be as simple as possible by leveraging off of the existing database design. Stemming was performed on the extracted metadata to automatically tag the keywords and phrases available. This was then fed into the recommendation model. The metadata extraction model allowed metadata to be generated for any dataset of any size, shape, or mix of data types.
One way to enhance the search functionality on the Information Hub is the incorporation of a Dataset Recommendation system. The expected input for this recommendation system is the input project name from the user, as well as the project metadata, which can be broken down into 3 levels of granularity, namely the project level, which contains the project name and project ID, the table level, which contains the different tables that make up a project, and the column level, which contains the different columns that make up each of the tables. This metadata then goes through the following steps: data pre-processing, feature engineering, and similarity computation, where the data pre-processing and the feature engineering is only done once and saved for a set collection of projects to optimize the system. For the data pre-processing, standard natural language processing techniques are used in conjunction with standardization of object-oriented programming naming conventions such as camel case and snake case, removal of very frequently occurring words to remove bias, and transforming the text data into a set format for the next steps. The first feature engineering method is the count vectorizer, which takes in the concatenated metadata words and produces an encoded vector. The second method is sentence transformer, which makes use of a small pre-trained language model to produce a word embedding. The last step is the similarity computation, which makes use of the word embedding or the encoded vector to calculate the cosine similarity between projects and produce the output. The recommendation outputs can be visualized and interpreted in 4 different graphs.
For future work, automated tagging could be performed on non-structured data as well, and similarly fed into the recommendation model for a larger collection of results to choose from. An evaluation feedback model could be implemented to score the usefulness of the recommendations and improve the model with use. Thank you.